Okay, so hopefully you watched my other video first, which explains how to graph in vertex form. And I hope you tried the problems on your own as well first. And now we're going to check to make sure that we got them right. So for the first example, my vertex is going to be +2, -4, because remember, you want to change the sign inside the parentheses, keep the sign outside the parentheses. I'm going to graph my vertex over 2, down 1, 2, 3, 4. And then I'm going to follow my pattern. Up 1 over 1, up 3 over 1. Up 1, left 1, up 3, left 1. And then I'm going to draw my parabola in. And I knew it opened up because it's positive. There's no negative sign. So now I can see that my transformation from the parent to my new function is I went right 2, down 4. The second one's a little trickier. There's two things going on. So I'm actually going to rewrite this function in a different way. First of all, there's a negative in front, which means that this specific parabola is going to open down. I wrote the equation this way because you'll notice there's a +3. What's really happening is we are subtracting a -3, and two negatives make a positive. So that's why when we're writing our vertex, it's really -3 as the x-coordinate. That's why I keep saying we have to switch the sign. So here it's a +2, here it's really a -3. There's nothing after the squared. So that's why I put +0 to show you that the y-coordinate for the vertex is really just a 0. So when there's something missing, you're going to put 0 in as a placeholder. So if I graph my vertex, I'm going -3 and 0. And instead of going up 1 to the right 1, I have to go down 1 over 1 because it should be opening up. Down 3 over 1. Down 1 over 1, down 3 over 1. And when I draw, I should have a parabola that opens downwards because of that negative. So the transformation from the parent function is all I did was go left 3. And opens down. And I just want to make a point that the fancier way for saying this transformation is that this parabola is reflected over the x-axis. So it's really being flipped over the x-axis, and now it's opening down. For the third parabola, you'll notice that I rewrote it again, and I put that +0 on just for clarification. So my vertex is going to be a +2, 0. So I'm going to graph that. And there's a plus, or there's nothing in front, so we know it's positive, so it's going to open up. So up 1 over 1, up 3 over 1. Draw my smooth line. And for this transformation, all that's happening is we are going right 2. For the fourth one, the vertex will be a +1 and another +1. I need to take note that this is going to open down because it is negative. So 1, 1 is my vertex. I need to open down, so down 1 over 1, down 3 over 1. Same thing on the other side. And so my transformation was that we went right 1, up 1, and open down. For the fifth one, I wrote it again above it because you'll notice that all I have is x squared. So just like this one where there was nothing afterwards, I put a +0. Since there's nothing inside with the parentheses, I put a -0 in as a placeholder. So my vertex for the fifth one is going to be 0, -4. So I'm going to plot 0 and then go down 4. This equation is positive, so I know it's going to open up. And then my transformation is just that this whole parabola shifted down 4. And then for the last one, the vertex is going to be a -1, +2. It's going to open down because it's negative. So we're going to go -1 up 2. I'm going to open downwards. So I'm going to do my pattern. And then my shift is we went left 1. So we went to the left 1, up 2, and we open down. So hopefully you got most, if not all of those correct. If you're struggling, please be sure to come to office hours so that we can go over some of these together. So here's an example of a homework question that you're going to have this week. I just wanted to give you one to model. So we're going to graph this equation right here, and we're going to find the vertex, the axis of symmetry. We're going to determine if it's a max or min, what the x-intercepts are, the y-intercepts are, and where the graph is increasing and decreasing. So the first thing we're going to do is we're going to find the vertex. So again, since it's negative, we're going to change it to a +2, and we're going to keep the -4. So that's the first thing I want to graph. So I put the vertex on there, and now I'm going to follow my pattern. Since it is positive, I know it opens up. So up 1, right 1, up 3, right 1. And if you really want to continue the pattern, after that it goes up 1, 2, 3, 4, 5 over 1. So again, up 1 over 1, up 3 over 1, up 1, 2, 3, 4, 5 over 1. So there's my parabola. For the axis of symmetry, I know that the axis of symmetry goes through the vertex. So I'm going to draw a line, and I'll do it in blue again, for the axis of symmetry going through the vertex. So there's my axis of symmetry. It goes straight down the middle. So the equation for the axis of symmetry, remember, is always x equals some number. So what's that number? It's where I cross the x-axis. So you can see I'm crossing the x-axis right here at 2. So my axis of symmetry is x equals 2. That's also the x-coordinate for the vertex. So that actually will always happen. Does this graph have a maximum or a minimum? Well, I'm going down, I'm hitting my lowest point and then turning. So since it's the lowest point, it's going to be a minimum. If I graphed correctly, I should be able to look here and figure out what my x-intercepts are. But remember, if you can't see them on the graph, you can always plug in 0 for y. So remember, that was a trick that we learned to find our x-intercepts when we did linear equations, and it works here too. But I can see them on my graph, so I will highlight those for you. The yellow are my x-intercepts. So the first x-intercept is 0, 0, because that's where it's crossing the x-axis. Here's my x, here's my y. And then the second one is 1, 2, 3, 4, 0. So I have 2 x-intercepts. My y-intercept, if it's not apparent by looking at the graph, remember you can plug in 0 as well for x. So what would that look like? Well, I would plug in 0 wherever I see x into this equation. So f of 0 equals, instead of x, 0 minus 2 squared minus 4. And then I would just follow order of operations. So the first thing I would have to do is P for parentheses. Remember our PEMDAS. So I'm going to simplify what's inside the parentheses first. So 0 minus 2 is still a -2. Then I would take care of my exponents. So -2 squared, 2 negatives make a positive. That's a +4. And then last but not least, I would do any multiplication or division, which there isn't any, so addition and subtraction. So 4 minus 4 is 0. Now, if I look at my graph, the point 0, 0 should be there. And so let's see, is that where we cross the y-axis? Yep, that's where we're hitting the y-axis at 0, 0. So you can either do it algebraically or by looking at the graph. So for the last two questions, I created a little cheat sheet for you down here. So every graph decreases and increases for a parabola. So when there is a minimum, we're coming down, we're decreasing. So this is the point of decreasing. Once we hit that minimum, we then go up. That is where we're increasing. Similarly, when there's a max, we're increasing first because we're working from left to right. We're increasing, we're hitting our max, and then we're decreasing. So if they want to know the interval where the graph is increasing, well, this is my minimum. Okay, we said when there's a minimum, the part on the right is where we're increasing. So we are increasing everywhere greater than 2, anything past this axis of symmetry. So where are we increasing? We're increasing anywhere where x is greater than 2. So there's our inequality. For decreasing, when we have a minimum, it's everything to the left, right? Because we're coming down. So we're coming down and then we're hitting our axis of symmetry, and that's where it goes back up. So anything before this line is where I'm decreasing. So anything where x is less than 2. Okay, so that's what you're going to write for increasing and decreasing. So again, if you have any questions, please feel free to come to office hours, and I'll be happy to answer any of them. Happy graphing!